Simple map that shows where we are, our final destination, and how to get there. Hello everyone and welcome to my channel. In today's video we'll create front-end system design for maps. We will start with functional and non-functional requirements. Next we'll discuss components and interfaces. Then we'll cover data structure and find the shortest path. Finally we'll talk about accessibility and performance. First, let's talk about the functional requirements. Our application will show a detailed map on the screen providing the rear view of the area of interest. So just display a map. We'll display the user's real-time position on the map, helping them understand their current location. Then, the map will display markers, routes, and other elements to enhance user experience and information. Users can zoom and pan to explore different parts of the map, making navigation intuitive and user-friendly. Users can search for specific location easily, helping them find places quickly. Then we will display pop-ups or info windows with details about locations. And finally, users can plan and view routes between different locations, making travel planning simple and efficient. Now let's move on the non-functional requirements. And the first requirement is performance. We will ensure our application has fast loading times and responsiveness, providing a seamless user experience. Also, our system will be designed to be usable by everyone, including those with disabilities. And will support multiple language and region content, making our application accessible to users worldwide. We have 6 main components: map, current location pointer, markers, search, path, and tooltip. The map can be represented as a set of images, one large image, or a canvas. We won't consider one large image due to potential performance issues in the browser. Let's consider using multiple images to help us build a map. The name of this part of the image is a tile or tile-based rendering. I will use a static tile size. This tile size is chosen based on research, but feel free to use another size. The number of tiles needed depends on the window size. For example, for this window size, we might need around 4 tiles, plus additional tiles for corners. The total number of tiles depends on the zoom level. Let's consider we have 21 zoom levels, where we need 1 tile for zoom 0, 4 tiles for zoom 1, etc. The total number of tiles is almost 6 billion. If each tile is about 50 kilobytes in size, we need to have almost 300 terabytes of storage for all tiles. Using S3, the cost is approximately 6,700 per month. It is manageable for a company or startup, and tiles can be updated periodically. We'll use SVG format for tiles because the vector data compresses better than images, so saves bandwidth. It makes possible dynamic updates and styling as well. Now let's decide how to render the tiles. We can use either SVG, images, or canvas. SVG has such advantages: resolution independent. It's else without loss of quality, ideal for free in zooming. Accessibility. Part of the DOM easily styled with CSS and manipulated with JavaScript. Then interactivity. Easily handles user interactions like clicks, hover, drags, etc. Styling. Flexible and easy to modify. From the other hand, we have such disadvantages. Performance. Slower with many elements because each element is part of the DOM. And complexity. Managing and updating DOM elements can be complex and less performant compared to Canvas. Canvas has such advantages. Performance. Faster for drawing and updating many elements, suitable for real-time and dynamic graphics. Control. Provides more control over rendering at the pixel level, allowing for complex animations and effects. And simplicity for dynamic content, more straightforward as it doesn't involve DOM manipulation. From the bad side, it has some accessibility issues, because it's not part of the DOM, making accessibility and styling more challenging. And interactivity requires manual handling of events. When to use SVG? When high quality, scalable graphics are needed. Interactivity and accessibility are important. The number of elements is relatively small and manageable. You want to leverage CSS for styling and transformations. When to use canvas? When performance is critical, especially with many elements. Fine-grained control over rendering and pixel-level manipulation is needed. Real-time updates and complex animations are required. The graphical content is highly dynamic and frequently changing. We will use Canvas for its performance benefits, because we have a lot of elements on the page, so it's very important to show fast and detailed information. Let's take a look at this example. We know arc location, window size, and zoom level. Right now it's just a default value. First step is to convert arc location to pixels ordinance as a given zoom level. Then we need to calculate the pixel bounds of the viewport based on the center pixel coordinates and determine the range of tiles that cover the viewport. After it, we need to fetch a tile image from the server and draw it on the canvas. Finally, we draw the arc location pointer on the canvas. So we have already added the arc location pointer component. Next, we need a marker with a tooltip. When we receive a tile, we can add JavaScript events to it. Since every tile is SVG, as we discussed, we need to find all markers and attach events to them. Then the component is ready. For the search feature, it's just an input field that receives a location name. Based on this name, we expect to get a list of locations with titles and coordinates. When we click on one of them, we should fetch new tiles based on the coordinates and display the new location. One more time, when users search for a location, it's better to reload the current screen to center the new location instead of scrolling. This ensures a smooth and intuitive user experience. However, users can interact with the map using mouse, wheel, and keyboard. Our map supports virtual scrolling, which means it dynamically loads new tiles as needed and removes tiles from the opposite side to avoid performance issues. For now, we will focus on creating a path between just 2 points, the user's current location and a selected destination. We have introduced a new component specifically to handle finding paths between these 2 points. The user sets the current location and selects a destination. The backend processes the coordinates and returns a zoom level where both points are visible. Client-side loads new tiles based on the provided zoom level, and we need to build and display the path on the map. To track the user's location, we will use a watch position method. This ensures we have real-time updates of the user's position on the map. After updating the location, a new notification is sent with the updated latitude and longitude, if the notification permission is granted and the map is elapsed. Now let's talk about data structure. On the client side, tiles are simple SVG files. Nothing too special here. On the server side, we manage all tiles as static files and update them when it's necessary, for example, 1 time per week. These tiles are stored in a file system structure based on their coordinates and zoom levels. This approach allows us to search tiles weekly and efficiently, reusing the same tiles for every user. We can use cloud storage like S3 for scalability, as I mentioned previously. But how do we find the shortest path between 2 markers and generate these tiles? All information from the map is represented as a graph. We dynamically generate SVG tiles based on this graph, including road details, and update them in S3. To find a shortest path, we use Dijkstra algorithm or A-star algorithm. Dijkstra algorithm is a well-known algorithm for finding the shortest path between nodes in a graph. It has such advantages: simple and intuitive, guarantees the shortest path in graphs with non-negative weights. From the other hand, and be slow for very large graphs, inefficient for graphs with many nodes and edges. A-star algorithm is an extension of Dijkstra's algorithm that uses heuristics to improve performance. It finds the shortest path more efficiently by prioritizing nodes that are closer to the target. From the other hand, it requires a good heuristic to be effective and be complex to implement and fine-tune. May not guarantee the shortest path if the heuristic is not admissible. Both algorithms have their use cases and trade-offs. Dijkstra's is more straightforward but less efficient for large graphs, while A-star is faster with a good heuristic but requires more careful implementation. Now let's talk about accessibility features. The first one is orientation flexibility. Ensure the map works seamlessly in both portrait and landscape modes. The next one is input purpose identification. Clearly identify the purpose of input fields to assist users. Minimum contrast. Maintain a contrast ratio of at least 4.5 to 1 for text and images to ensure readability. Screen reader support. Highlight a section of the map with a square and provide a numbered list of places within that area for screen reader. This custom solution involves parsing tiles to include all available markers. And the last one, feedback mechanism. Offer feedback live vibrations or sounds to confirm actions, such as sending notifications for new locations. Now let's talk about performance optimizations. Tile caching. Cache frequently access tiles on the client side, using server workers to reduce load times and server requests. Debouncing user interactions. Implement debouncing for rapid actions like panning, searching, and zooming. The next one is virtual scrolling. Load and render only the visible tiles. Lazy loading. Delay loading non-critical elements and tiles that are not immediately visible. Optimize SVG assets. We need to compress and optimize SVG files to reduce load times. Web workers. Use web workers to offload heavy computations, such as path finding, keeping the main thread responsive. And CDN. Utilize a CDN to deliver tiles and static resources efficiently. By implementing these features and optimizations, you can create a map application that is not only accessible to all users, but also performs exceptionally well. That's all for today's video. Don't forget to like and subscribe. See you next time. Bye.